Well, hi everybody. I want to walk you through a couple of circuit problems. Today we're just going to do simple circuits. And again, simple doesn't mean easy. Simple just means we have only one type of circuit. Okay, just kind of like when we did simple kinematics, it was motion in one direction only. A simple circuit is going to have only one type of circuit, either series or parallel. So let's start with the easiest one. That is problem number 1 here. This is a series circuit. I can tell it's series because my current only can travel one path. Okay. So the first thing that we need to do whenever we're confronted with a circuit is we need to get what is known as the total resistance. So my total resistance is going to be, for a series, it's going to be the sum of the resistors. So for this problem, I have 3 resistors. 1, 2, 3. This is my battery. That's not a resistor. So all I'm going to do is add them together. So that's 15 plus 10 is 25, plus 5 is 30. So 15 plus 10 plus 5 gives us 30. Okay, so total resistance is 30 ohms. Now to get the symbol for ohms, I'm going to go up here to insert, symbol, and I have mine right there. You may have to look for yours. Okay, now that I know my total resistance, now I'm going to be working with Ohm's law to find my current. My total voltage is whatever the battery says. My battery says 12, so that's my total voltage. Now I'm going to use my Ohm's law. Ohm's law states that V, my voltage, equals I, my current, times R, my resistance. So my total current is going to be my voltage divided by my resistance, or 12 divided by 30 gives me 0.4, and the unit for current is the ampere, or we can just say amps. So I've got 0.4 amperes. And I wrote that wrong. There we go. Okay, now that I've got my totals, now what I want to do is figure out my individual currents, my individual voltage, and my individual power. Now, one thing to remember here is that in series, current is constant. Okay, so all resistors will have the same current, which is the same as my total. So this is 0.4, this is 0.4, and this is 0.4. Once I know that, it's easy to find the voltage. So the voltage is found by saying I times R. So the voltage on my 15 ohm resistor would be 0.4 times 15. And that gives me 6. The voltage on the 10 is equal to 4.4 times 10, or 4. And the voltage on the 5 is going to be 0.4 times 5, which equals 2. So 4 and 2. Now, here's the great thing about circuit problems. They kind of have a little fail-safe built in so that you know you've done them right. In series, the voltage should add to the battery. So our battery was 12, so we're going to check 6 plus 4 is 10, plus 2 more is 12. That does add up to what my battery is, so I know I did it right. Now the last thing that I have to do is find the power. Power can be found a variety of ways, but the simplest way is to just say I times V. So the current times the voltage. So the power on the 15 is going to be equal to 0.4 times 6, which is 2.4. And then I will do the same thing for the other two. I'm going to do that real quick in my calculator. That gives me 1.6 and 0.8. Okay, now I can check the power too the same way, just by adding up 2.4 plus 1.6 is 4. 4 plus 0.8 is 4.8. And then it should be equal to the total current times the total voltage. So 0.4 times 12 does give me 4.8. So I know that I did that correctly. Okay, now what you're probably going to want to do at this point is pause this recording and solve problem 2 on your own. I'm going to now continue with problem number 3. Okay, for problem number 3, this is now a parallel circuit. I can tell it's a parallel circuit because I have a big branch here. My current, when it comes in, it splits. It splits and doesn't remain as one till it gets to the other side of that branch. So parallel resistors are added inversely, meaning I take the reciprocal of them. So I'm going to have to say 1 over 10 plus 1 over 15 plus 1 over 5 and get an answer. That is not my resistance. My resistance is the reciprocal of that. Okay, that is equal to the 0.3667. That's the reciprocal of my resistance. My overall resistance is the reciprocal of that answer. So I get 2.73. Okay, and again, that is ohms. Now, here's a little way you could tell you've done that right. When I add resistors in parallel, my total resistance should be lower than the lowest value. So my lowest value was 5. That is lower than 5. I know I did that correctly. Now, I'm going to come down to my total voltage again. That is my battery. Okay, so I'm just going to fill that in with 12 volts. And now I'm going to get my current, same way I did before. I is equal to V divided by R. So that's going to be 12 divided by 2.73. And I get 4.4. Current in parallel tends to be higher, significantly higher than it is in series. Okay, now I'm going to start to fill in my chart. Resistors in parallel, or parallel circuits, I should say, I'll say resistors. all have the same voltage. Okay? Which is whatever the voltage of the battery is. So this is 12, that's 12, and that's 12. That's the thing about parallel. They look a lot scarier, but they're really a lot easier. So now I'm going to find my current, just the same way I did before. I is equal to V divided by R. So the I on the 15 is equal to the voltage divided by the resistance. So that's going to be 12 divided by 15, which gives me 0.8. And then I'll do the same thing for the other two. So the I on the 10 is equal to 12 divided by 10, which is 1.2. And the I on the 5 is 12 divided by 5, which is 2.4. So let's fill that in, 1.2 and 2.4. Now I'm going to check again, just like I did before. The current should add up to my total. So 0.8 plus 1.2 is 2, plus 2.4 is 4.4, which is exactly what I got before. Now I'll find my power, same way I did before, I times V. So the power on a 15 is going to be 0.8 times 12, which gives me 9.6. And then the power on the 10 would be 1.2 times 12, which gives me 14.4. I'll do the same thing for the 5. Let's see, 14.4. And then power on the 5 is 2.4 times 12, or 28.8. Now, before I end this, I want to point out a couple of things. Notice here, the power, the highest power, is drawn by the lowest resistor. If these were light bulbs, this 5 would be the brightest. It would burn out the fastest because it's using the most power, okay, but it would be the brightest. If I look back and compare that to my series circuit, it's the opposite in series, where the highest resistor has the greatest amount of power. The other thing to point out is the power in a series circuit is much lower than in a parallel. Okay? Okay. Now, that's about the end of my little video. If you have any questions, please send me an email. Don't be afraid of circuits. If you follow the rules, you'll get through them. Okay? Have a great day.